Hello, my good friends. Today's lesson is going to be on base E and natural logarithms. So get yourself a paper and a pencil because we're going to be doing some thinking. And when we think, we should be writing to give form to our thoughts. And when we write, we should also be thinking to give precision to what we mean. And you'll also need a scientific calculator. But first, let's look at defining the number pi. You recall, maybe you're from 4th, 5th, or 6th grade or something like that. The pi is just a number, and it's approximately equal to 3.14159, and then it goes on forever and doesn't ever stop and doesn't ever terminate. It's one of these fundamental constants. When I was in school, I remember being told that pi was, oh, use 22/7 for pi, and then come to find out later, oh no, that was just an approximation. You can't actually write pi as a fraction. Doesn't work that way. But I don't mean what is its value. I'm asking what is its definition? Where does it come from? So, well, something involving a circle, right? So if I have a circle here with a radius r, pi is actually defined as the fraction of a circle's circumference to the diameter. So if you take a circle's exact circumference and you divide it by its exact diameter, you get pi. And of course, it's very difficult to do that with measured things, but we're talking about abstractly with exact values. Was one of these fundamental constants. And this is where we get, if I multiply both sides by diameter, I get the little formula C is equal to the diameter times pi or something like that. And then if you remember, the diameter is equal to 2r then times pi. And so this is where we get the familiar formula C is equal to 2 pi r. So that's by way of a little review. Let's also review this. What question does a logarithm ask? It asks, what's the exponent? So if I had something like 3 squared is equal to 9, how do I write that as a logarithm? Well, logarithm says what's the exponent. I would write it like this. I would say log, the base is 3, of 9, and the answer to the logarithm question is 2. What's the exponent on 3 that gives me 9? So this then becomes log, the base goes down here below as a subscript, the power goes there, and I always put parentheses around my power, and that equals then the exponent. Okay, so logarithm asks what's the exponent. Now, 3 is an okay base, like there's nothing wrong with 3. We've had lots of other bases. But there's a special base, a base that shows up naturally, sort of like pi kind of showed up as a natural property of like the physical universe, like it's kind of just built in. There's a built-in base. That base is called the natural base E. And it's 1/2 where I am. Okay, the natural base E. E is just some number. It's a number like pi. E is approximately 2.71828 ... It goes on forever. You cannot write it as a fraction of integers. Now, there's a couple different ways to actually define E. I've seen it done, I'm thinking at least twice. There's 2 different ones that I'm aware of. Maybe there's more. But this is the more common one here. This says, as n approaches infinity, the expression 1 plus 1 over n to the n approaches E. Now what that means is this, I'll just do it with parentheses here and with the infinity. So that means 1 plus 1 over infinity to the infinity power. That equals exactly E. Okay, but you can't ever do it. You can't ever take something to the infinite power because you never can get there if you multiply it infinitely. And 1 divided by infinity, like what does that even mean? So this is where we get involved to the idea of a limit. And if you do limits in calc, you'll remember this conversation hopefully. Okay, so let me just do this for like an example. Let's let n is equal to then just 100 and see where we are. So as n goes to 100, I get the expression 1 plus 1 over 100 raised to the 100. What does that equal? So get out your scientific calculator and plug that in here. I'm using my TI-84, and I'm going to do parenthesis 1 plus 1 divided by 100, close parenthesis, raised to the exponent of 100, and I get this decimal 2.7048. Dot dot dot, because it's an approximation. Okay. Gee, how did that compare then to actually the value of e? Well, it's getting pretty close. Okay. And if you made the exponent here higher and the denominator there higher, if this is let n is equal to 10,000, 1 plus 1 over 10,000 to the 10,000, you would get closer. All right. So what this tells us is that we've got a natural base that occurs kind of in nature. That seems redundant because it's natural, it's in nature. And so we've got 2 different functions now. We've got an exponential function that involves e as the base, and we can have a logarithm function that involves e as the base. When you're going to do e as an exponential, you can do, say, something like e to the 5th. That's just a number. Okay, but how do you do logarithm? Logarithm with base of e here of x is not really written log base e. Since it happens so often, it's the natural way that things maybe have that grow or decay have a base. You don't write it as log base e. Just like in the same way, if we had log base 10, you wouldn't write the 10 because that's the common logarithm. Log base e is written a special way. It's written as ln with no base written down there of x. This little statement right here says the natural logarithm or the logarithm natural of x, which means log base e. And so sometimes I will even tell students, hey, when you see a natural logarithm of something like ln of 3x plus 5, you can say, well, what's the base? Well, just write the base in there, write the base e. Now that's a little bit simplistic, right? You should get to the point where you understand that the base is e without having to write the base e in there. But for right now, it can be useful to help you understand what's going on. So the functions f of x is equal to e to the x, and f of x is equal to the natural logarithm of x, then are inverse functions. Okay, so as you recall before, if we had something like y is equal to 2 to the x, the inverse function would be y is equal to log base 2 of x. Those two kind of go together. So these two then go together. Those are inverse functions. All right, so get your scientific calculator out and let's do this. Evaluate e to the 5.7. So it's just some number. We're going to type it in. It's going to be a decimal approximation. Where do you find your base e? There's a special button on your calculator for that. For mine, it's next to the 4. If you look to the left of 4, you will see a button that says ln, which we'll get to in a moment. And if you look above that, it's got e to the x. So in order to evaluate that, I'm going to press the blue button, which is second. And then I'm going to press ln, which gives me the e to the x function. And I get an e with a little exponent that jumps up top. And I'm going to type in 5.7. And then press enter, and it's just going to give me a decimal approximation. That's 298 points. I'm going to go to 4 decimal places, 8674. Okay, so just some practice on how to evaluate that with a calculator. And then natural log of 2.3. So again, I'm just going to evaluate this on the calculator. I'm going to use that ln button, so the one that's right next to 4. Okay. Natural log, and it opens up parentheses, and I type in 2.3, and it closes it, and I get 0.8329. All right. Now, the exponential one's not that difficult. That's equivalent to me taking 2 point, what was it again? Do you remember? You probably need to commit this to memory at some point. 2.71828 raised to the 5.7 is approximately 298.8674. Okay, but this one's a little stranger to you. What's the base here? The base here is e. And so if I do the log loop, then what this means is e to the, whoops, I don't know why I did that. I get e to the 0.8329 is then equal to 2.3, or approximately, because we're doing decimal approximations. Okay, so natural log means log base e. All right, so now let's do an example. Write a logarithmic equation equivalent to e to the 2x is equal to 7. All this is asking us to do is convert this into log form. So to be real simple to start off, log, what's the base? The base would be e. What's the power? 7. And what's the exponent? 2x. Not done yet because log base e is a little silly. So this now becomes natural log of 7 is equal to 2x. And there's my answer. Notice I'm writing kind of the L and the N for natural log in like maybe a cursive or an italic sort of a thing. Sometimes if you just write LN, like not sure what that means. Does that mean one N? The handwriting can be a little confusing. So it's typical to write it in like an italic or a scriptic sort of a font. So there we go. That was all that was involved with that one. Example number 2, write each logarithm equation in exponential form. Okay, so I'm just going to rewrite this in exponential form. What's the base? Base is e. So just do the log loop, all right? So e to the 0.3345, that's equal to x. There we go. Done with that. Okay, and then this one, natural log of 42. There's my power. So what's the base? E, if you need to write it in there. Okay, so then do the log loop. This is e to the x is equal to 42. There we go. Easy peasy, right? Okay. So remember, a natural log means a logarithm with the special base of e. Okay, now all of the properties of logarithms and exponential things that we did earlier still apply when we're using base of e. So to solve this equation, here's what I'm going to do. All right, so there's my equal sign. Where's my variable? The variable is right here with x. Oh, it's in the exponent. And what's the base? The base is e. What I need to do is I need to isolate this little package right here. I need to get e to the 2x by itself. So I'm going to subtract 2 and divide by 3. In that order, if you divided everything by 3 first, you would get 2/3 and 10/3, which is a problem. I mean, you could manage it probably, but it wouldn't be comfortable. So let's do it comfortably. Let me subtract 2 from each side. Minus 2, minus 2. This cancels. 3 times e to the 2x, that equals 8. Okay. Now divide by 3, divide by 3. This cancels. I get e to the 2x is equal to 8/3. Okay, now how do I get rid of the e and get the x out of the exponent? What I'm going to do, whenever you see e as a base and you're solving for the exponent, what question gives us the exponent, right? Logarithms. So logarithm of what base, though? Log base e, which is natural logarithm. I'm going to take the natural logarithm of both sides. I'm going to do natural log of the left, and I'm going to do natural log of the right. I don't know why my 2 or my 3 turned into a geometric figure down there, but my iPad thinks I want to do geometry, which I kind of do, but anyway. Okay, now natural logarithm, log base e, of e to the 2x is just simply 2x. And that's going to equal then natural logarithm of 8/3. Hey, why did the left simplify just to 2x? Well, think about it. This question says, what's the exponent on the base, which is e, that gives me e to the 2x? Don't you see that the exponent is just 2x, and that simplifies down here like that? Okay, Good. All right, so now I'm going to divide the left-hand side by 2 and divide the entire right-hand side by 2, and that cancels, and so I get x is equal to, oh yuck, a compound fraction. Rather than dividing the right-hand side by 2, I think it would be simpler if I just multiplied by 1/2. So I would write 1/2 times natural log of 8/3, and that looks a little cleaner. That's like a calculator-ready solution right there. If you didn't have a scientific calculator, that would be as far as you could go. But then to do a decimal approximation, you pull out your calculator, and I'm going to type in probably 0.5 would be easier on this case rather than a fraction. So 0.5 and then the natural log button, and then I'm going to do 8 divided by 3 and then close the parenthesis. And that gives me approximately 0.4904. And if we're solving to decimal places, that would be how far I would go. Okay, now let me do one more with you. That's solving if you've got, starting out with a base of e to an exponent. This is an exponential expression or exponential equation. How would you do it with like a logarithm equation? So this is now natural log of the quantity x plus 3. Notice how the parentheses give you the argument of the logarithm, give you the power. Minus 5 is equal to negative 2. Okay, just for help here, base e. What I want to do is I want to isolate this package right there. Okay, so I'm going to add 5 to the left and add 5 to the right, and this cancels. And so I'm going to get natural log of x plus 3 is now equal to negative 2 plus 5, that would be 3. Okay, now I've got everything but my natural log expression moved to the right. What I'm going to do then is rewrite it as an exponent. So the base is e, do the log loop, and so I get e cubed, there we go, nice save. E cubed is equal to the power x plus 3. How do I solve this for x now? Subtract 3 from the left, subtract 3 from the right. This cancels, and I'm going to spin the whole thing around. X is equal to e cubed minus 3. Now remember, e is just some number, so it's some decimal cubed minus 3, and that would be my answer then if I were doing just a calculator-ready solution. Or x is approximately equal to, pull up my calculator, and I'm going to go second e to the x cubed, e cubed, and then I'm going to use my arrow button to get out of the exponent, minus 3, and I get a decimal approximation of 17.0855. Okay, there we go. And that's all for today. So may your day be merry and bright, and may all your mathematics be right.